to a new edition of the Heat Treat podcast. Today we have a very special guest. We have done a lot of logistics and scheduling but now we have Roger Jones, CEO Emeritus of Solar Atmospheres, Inc. So first of all, how you doing, Roger?
I'm doing good, Carlos, and thank you very much for having me on your podcast today.
No, not a problem. My pleasure, and really looking forward to talk about vacuum furnaces, solar atmosphere, which is an icon on the heat treat in the United States. And if you could just give us, like the basic who solar is, their services, their reach, and a little of the history of the company and the role you play in it. So why don't you give us a solar introduction?
Not a problem. Well, thank you. Let's start with the history first. I think that would be the easiest way to go. First of all, we're a family business. My father started the business, the actual commercial heat treating business, in 1983. Actually, my father and my mother. So we are a family-owned business. We grew out of the furnace manufacturing business. They had a company called VFS, which was called Vacuum Furnace Systems. So we actually started out by more or less cutting our teeth on the building of these vacuum furnaces. And we knew over the years that the commercial heat treating business is very, very profitable. You can make a lot of money in the business, particularly if you're a quality shop and you do a good job and you satisfy your customers' needs. So that's what we looked at. So in 1983, we started here in Souderton, Pennsylvania. We're roughly 35 miles northwest of Philadelphia, Pennsylvania. And the business grew, expounded. It really caught on. A lot of our competitors in the area kind of said, well, why are you getting into the business? There's enough commercial heat treaters in the area. But one of the things that we keyed on is we are strictly a vacuum shop. In other words, we only do vacuum processing. So even back in the early 1980s, we were a mean and green company. We did not do anything open fire or oil quenching furnaces of that nature. So we were a very environmentally friendly company, and we continue to grow on that today. The business continued to expand and grow. We were doing a lot of titanium processing for some facilities out in Ohio and Western Pennsylvania, which led us to the formation of our second facility in a town called Hermitage, Pennsylvania, which is roughly 35 miles northwest of Pittsburgh, pretty much on the Pennsylvania-Ohio border. And we installed big vacuum furnaces out there. Some of the furnaces today, there's one that's 48 foot long doing commercial.
I got a question over there because I believe it's quite important, but your business model is you do design and manufacture your own furnaces. Will that be accurate to say?
It's accurate, but we have sold vacuum furnaces to our competitors. We're very open about that. Many times I've been here on the floor and a competitor will come in with our sales team, and we're very open about that. So we've shared a lot with our competitors and the industry in general. So we don't hide our light under a bushel, so to speak, if you know what I mean. We just let it go. But anyway, back to the so we started the Hermitage facility, and that facility was primarily processing, and it continues to today, titanium products as well as other products, as well as we have a large program with Boeing on the 787 program for the C-Trax. So that's been a very interesting project as well. Our third facility that we opened up was in Southern California in a town called Fontana, which is on the east side of Los Angeles, roughly 35 or 40 miles east. And here again, the same mantra. Southern California is a heavy aerospace and aircraft area, and we've done a lot of work in that area, developing the processes. As well as we opened a facility in Greenville, South Carolina. We purchased a building down there, and same thing. We're doing power generation work, aerospace and aircraft, metal processing in that facility as well. And just recently, we purchased a company up in Michigan. It was owned by called VacMet, and the owner wished to retire. And we've known the people, the Guno family, for a long time. And Mr. Guno decided to retire. We bought the business, and we're building that up as well. So we have currently five commercial heat treating plants throughout the United States. And let me touch a little bit on our furnace building, which is called solar manufacturing. So you are correct, Carlos. We do purchase and have all of our vacuum equipment from solar manufacturing. So we do a lot of R&D for solar manufacturing. So when they have customers that they're looking for specific products and things that need to be processed, we do them in our facilities to prove the process that they're looking to achieve. So it's sort of a hand in glove and a win-win situation for both of us. So I think that pretty much explains the facilities and the businesses.
So it's 5 commercial heat treats in total, spread all across the United States, and 1 manufacturing location. So six business divisions.
Yes, the manufacturing facility is here in Sellersville, Pennsylvania, which is only about 5 minutes from where I'm at.
So now let's talk a little bit more of the leadership role and the CEO running 5 commercial heat treats, on different locations with different markets, maybe different applications, different process, different customers, different geographies, different time zones, right?
Yes, right.
It may be challenging. So during your career, what is the most significant challenge that you faced as a CEO of the companies and in the heat treatment industry, and how have you addressed them? Right now, we went through COVID. There's been a couple of depressions on the economy, which do you recall was like the thing that marked you?
Absolutely. Well, first of all, in my CEO position, which currently I'm not in, I'm CEO emeritus. So I'm actually working directly for my father on various research and development projects, as well as other projects within as we call it, the Solar Nation. However, when I was CEO, we established in each of the commercial heat treating facilities presidents who we've learned to know over the years. For instance, in the Hermitage facility, we have a gentleman by the name of Bob Hill. And Bob Hill actually ran a commercial heat treat facility in Southampton, Pennsylvania, very close to us. And I had developed a really good relationship with Bob. And long story short, that business closed up and we were able to acquire Bob. And Bob worked here in Souderton for quite a while till we established the facility in Western Pennsylvania. And that's where he continues to run. So establishing good connections with people and having them work for you is really great. The same situation was in our California facility. Derek Dennis was actually one of our customers. And we actually approached him and said, hey, Derek, would you like to start up a commercial heat treating facility in Southern California? And he jumped at it. And it really, it's turned out to be a great blessing in both of those facilities, which are great processing and bellwether type work. They're banging it out of the park for us at all the facilities. The same for our South Carolina facility. Steve Prout, who we knew through the industry, here again, was someone who we knew and we trusted and put in place. So sort of answer your question, Carlos, finding good people, particularly today, can be hard. But we have a board of directors, so we meet on a very regular basis. We can connect even here, like through Zoom, with our plants and have discussions about things, as well as face-to-face meetings. So that's been a big part of it, is the people thing. The other challenge I had when I was here in Souderton was the cost of electricity. These vacuum furnaces, they chew up a lot of power. We put in a program here that we piloted years ago where we're conserving electricity. For instance, the heating rates of the furnaces, we don't heat them very quickly. We try to heat them slowly so we don't blow our electrical demand, which can be a big problem at the end of the month. If you do that, you end up paying your utility company a large sum. So we've looked at our heating rates in the vacuum furnaces, as well as we've made the hot zones much more uniform with graphite insulation. The graphite hot zone has been a real technology changer. We do have metal hot zones for certain types of processing like titanium and medical products, but the down and dirty furnaces doing a lot of the grunt work is the graphite hot zone furnaces, which are much more energy efficient than the metal hot zone furnaces. As well as we've looked at things like diffusion pumps, making sure that they're not running on the high power all the time. We put them on a lower power when they're not needed. The same with motors and lights. So corporately, we've done that, and we've been able to save money by just looking at our electrical costs. The same with quench blowers, not letting the quench blower run any longer than you have to. Or a lot of these quench motors have variable speed drives, so we can slow the motor down and save electricity. So I would say those two things were challenges that I worked with, and we've been successful in implementing them.
So a follow-up question regarding what you just mentioned regarding cost of electricity. So on the different locations that you have, one in California, you mentioned Michigan, you're in Pennsylvania, does the energy cost varies a lot?
Yes, it does. As a matter of fact, let's talk about California for a minute. As you probably know, California here in the United States is one of the highest electrical prices in our country.
Mm-hmm.
And what we did in the California facility was something very interesting. We actually spent quite a bit of money, and we put in a solar-powered battery backup system. So in other words, we have if you go to our website, you look at our California facility, you'll see these solar panels on top of our building and in the yard. And what they're doing is they're collecting energy and they're storing them in batteries. So what we can do is on off-peak hours and other times, we can actually use that power and not have to worry about throttling way back our equipment, particularly at nighttime during the day when people want us to cut back on power. So that was one of the biggest things that we did. But you're right, each facility has its own challenges with electric, and California being the worst. And that was one of the things we did there. The other plants pretty much have the same mantra that we've done here, is we've looked at, saving power with the hot zones and the pumps and the all the things in general like that.
So now let's move a little more into the application. As you mentioned, solar is well known for vacuum processing. I didn't know it was just the strategy was like, we're just going to go flat on vacuum and we're going to be the experts, which I believe you do great. And I love the branding, the yellow, the solar thing. I just love it. I think it's very powerful. But now let's talk about applications. When in all your marketing, I know you do a lot of aerospace, you do
Yes.
medical, you do government work, but can you share a little bit, or how do you work with your customers? Do they approach to you with a part, with an application, and will you design the process for them, and how that designing process goes through with the customer, or do you just get parts that have a specification and you run them through?
It works both ways, Carlos. We've had people come to us with a problem and say, hey, I've got this part or a series of parts, and we're having some issues with it. And we sit down with a customer and we go through and figure out, how can we solve your problem? Let me talk to you also a little bit about problem solvers. Our company is, we can only do so many things. We're members of the Metal Treating Institute. So if we have a customer that comes with us with a problem that we can't solve, we try to steer them into the direction of somebody who we think could help them.
Sure.
For instance, if it's a open fire type process or an atmosphere carburizing, we don't do that. We do vacuum carburizing. But here again, that's strictly certain materials and certain alloys. But also, we work with specifications too. You're right. There's the NADCAP specifications, the aerospace specifications. We have to abide by them. Strictly in the commercial processing, if it's something that's not for instance, the tool and die industry, which is an interesting industry, a lot of the work there is pretty much uniform. It's pretty much set in stone. There's not a lot of changes there in that. However, in the aerospace industry, the medical industry is a big one. You have the FDA that we have to work with because they have specifications, as well as we're members of a quality group called Medicred, which is driven by the FDA. So they have all these specifications we have to work to. Primarily, the medical parts run in. We have medical rooms in here in Souderton, as well as in our Hermitage and all of our facilities for just processing medical parts, which are all metal hot zones, as well as environmentally controlled atmospheres. For that main reason, you're processing medical parts that must be in a controlled area, and they can't be out in a shop where there's smoke or flames or heat, and humidity is a big one too. So pretty much that's what it boils down to.
And just also a follow-up question, because I'm not an expert or have ever been exposed on to the medical market on heat treat. I've been exposed to automotive, oil and gas, of course, aerospace, constructions. But you're right. I mean, when you're treating medical stuff, I mean, you don't want any dust or fumes of air or so. Can you share a little bit for the guys that don't do much with medical, how is to work with the medical industry? I mean, we talk about NADCAP, which I believe everybody knows that it's pretty intense and heavily on traceability and uniformity. Of course, automotive, which is a little more industrialized, very big volumes. But when we talk about medical, it's not very dense or heavy objects, right? But they have to be, I will assume some of them are stainless steel or titanium, right?
Correct.
But,
Yep.
how is it to work with the medical industry? I mean, you could just expand a little on that thought.
Sure. We've developed great relationships with medical customers that come to us. Now, you got to remember, we're not doing the work directly for like a J&J or somebody like that who's it's a second tier type supplier. So their customers are coming to us with, for instance, a great example is a medical implant. I actually had a medical implant about 5 years ago, a titanium knee that was done. And I wanted to make sure that knee was processed in one of our vacuum furnaces.
You traced that knee implant?
I wanted to make sure, well, let me put it this way. I wanted to make sure that the company that we processed that implant for which was being done in our facility. So
that's a hell of a story. I believe that's the greatest story ever. Right.
Yeah. Well, it's a story of life, Other things like, for instance, there's a thing called a heart wire, which is when they it's a stainless steel wire that they insert into an artery where they put a stent into you. That has to be processed to a certain metallurgical processes, as well as the stents themselves. Also, tools that are used in the medical industry, like, when they're doing operations and whatnot, all those materials are heat treated. Now, here again, like I said, we're not working directly for we're working for second tier people who supply to the medical industry, and that's 99% of the work. That's the way it goes. There are a few customers that we work directly with, but basically that's what it boils down to, and they are very good to work for. We haven't had any issues, and we work out processes and programs, and a lot of it's already either they have it or we develop it with them.
Okay. Thanks for sharing that. The medical industry is new to me. So now my follow-up question will be on technological advancements and innovations. You mentioned about open fire, how the environment is perceived on a heat treat. And I have been in your facility in Pennsylvania, and it's state of the art. I mean, you call it on the floor. So I just want to say that, very impressive with that facility. But what are the new technological advancements or innovations that have recently shaped the landscape of commercial heat treatment, and how they have influenced your operations? There was Industry 4.0. Right now, we're seeing a lot of AI. On your case, additive manufacturing, it's over there. But, there are like trending topics, but fashionable. But is there something that we're missing in those trending topics that we just give it that it's done? I mean, it's automation, trays, quenching media, new ways to heat things up or to save money. What's your vision there? What have you seen that has evolved since you started in 1983 to nowadays?
Sure. Well, we'll go back to 1983. Since you brought that up, you've asked a lot of questions there. Let me try to address that. Just a
Sure,
couple of them.
we got time.
Yeah, that's true. Let me just say this. We thought that we would never have an atmosphere oil quench furnace or even type furnace like that. So over the years, we saw the need for a vacuum oil quench furnace. So we spent several years designing and engineering our own vacuum oil quench furnace because we saw the need for that. And by the way, this is a green furnace. By that, I'm saying there's no such thing as flames that are coming out of this thing or whatever. It's actually a vacuum chamber, which is run in a partial pressure nitrogen atmosphere, and the quench tank is all sealed as well. We've installed this furnace in our Hermitage facility because that area, we saw the great need for that type of processing. So that furnace has been up and running for about a year and a half now, and it's done very well. And it's done a lot of, we're not just doing pennies on the town type work in that furnace. We're doing high-priced, high-dollar aerospace and aircraft type work in that furnace. So, and we're getting very good results out of that furnace. So that was one area that we looked at expanding upon, and we see that there could be more of that in some of our other facilities as well as the market and as the time lends itself to us. I'm sorry, what was some of the other questions you had?
I would just like to go a little further on that furnace. I mean, just want to understand why will oil quenching would how will it'll be deferred to vacuum high pressure gas quenching, right? I mean,
Correct.
As you mentioned, which I very agree. I hate when it comes like you're a vacuum guy, we're an atmosphere guy, we cannot coexist. No, wait. The parts, sometimes they receive the process this way the best, right? Sometimes the process, it goes the best types of steel. You cannot take an atmosphere furnace, all the way that you can. I'm talking about temperature all the way, but about quenching media, what was the driver to quench parts on oil?
Okay, yeah, that's a good question. Let's just answer it this way. In high pressure vacuum furnaces, for instance, 10, 20 bar and even higher. Now we do have furnaces that are 10 and 20 bar, quite a few of them actually, and we've developed a lot of processes around that. However, there are specifications out there where high pressure gas quenching at those pressures is still not, first of all, metallurgically, it may not get the end result that you're looking for. And secondly, the specifications state that you can't do it that way. It must be quenched in oil or water or brine or salt, whatever the end might be. So what we did was we looked at those alloys that we're looking to process, 4140, 4340, 8620. We can do some vacuum carburizing in that furnace as well. So we're able to do that. It's a multi-type use furnace, and we made it so, as I mentioned earlier, it's got a nitrogen atmosphere. So there's no, when you load the furnace cold, just like loading a vacuum furnace. You close the door, you pump it down, you heat it up in a chamber to the temperature you're going to, and then when you reach the temperature, and by the way, we're using work thermocouples on these parts. We're not just going by the rule of thumb that, inch per hour, et cetera. So we're getting real-time temperature data at temperature, and then when we go to quench, the door opens up and it goes into a oil quench chamber. It closes, and then of course we wait for the period of time when it cool enough, and we bring it back up, then bring it out. So in the meantime, that vacuum chamber is cooling down. We have a quench motor on there, so we don't bring the parts up and out of the furnace until it's roughly 200 degrees or so, and then we bring them out, and then we wash them, and then we temper them in a separate temper. So in some of the instances, we're doing the same as you'd be doing in an atmosphere, particularly with the washing and the tempering. But with the actual vacuum processing itself, it's all done in vacuum, and it's worked quite well.
Thanks for answering the question. The other topics I wanted to talk to you about were Industry 4.0. Since 1983, when you start building the furnaces, the electronics or the charts, the controllers were not as fancy as today. Do you think that play a major role on commercial heat treatment when we started to have digital controllers or analog controllers, and how do those impact the industry?
Oh, absolutely. Going back in history over the years with the old chart recorders, had the pens that would be all messy and they wouldn't work, and you'd have to, play with them. And I hear you. And those days are long gone. Everything today is electronically. Our sister company, Solar Manufacturing, has an actual controls package that they sell with every furnace. It's called the Solar Vac. And what that does is it's a package system. Everything is electronically controlled. You can put your pre-programmed recipes in and pretty much push the button and walk away. And a lot of it's done automatically. It takes a lot of the operator interface out, like we had to do years ago, where you had to check the furnace on a continuous basis. But now it's a much easier way of doing it. So that's one thing that we've worked hand in glove with our furnace manufacturing. We give them feedback, what we see in the industry, and they've come forward and produced these things that we need. The same with the chart recorders. We've used a company called Eurotherm, it's a standard chart recorder, which is, it's electronic and works great. So I can actually go to my house and I can actually dial up my computer and I can look at any furnace in the company, what it's doing. I can't control it, but I can look and I can monitor it and see what's going on. But there's been a tremendous advancements today with controls and controlling the process and moving forward to where we were back in the 70s and 80s. Believe me.
Yeah, I don't see how nowadays aerospace or even an automotive company that runs heat treat can still operate with those pen charts, for all the traceability. Right. It was done that way, but now with everything is very easy and accessible with the digitization of things. Now let's talk about additive manufacturing, which is very attached to vacuum in this case.
Correct.
Have you seen a big impact on the industry with that?
Absolutely. Actually, I gave a presentation to several ASM chapters years ago on additive manufacturing. This goes back about 5 years ago, and it sort of gave a overview of where we see additive manufacturing back then, and I can tell you where it is today has really grown. General Electric, for instance, has really brought into a lot of additive manufacturing parts in some of their jet engines, particularly fuel nozzles and things like that. Their plant in Cincinnati has a whole center set up to do that. We've processed vacuum process additive manufacturing parts on a regular basis. And by the way, it's been a learning curve over the years because, as you know, there are various ways to print and produce these additive manufacturing parts. We've had the hard way. We've learned experiences where if there's some powder left in a blind hole, which could blow out and could cause damage into the hot zone, these base plates that the parts are on are a part of it as well. So we've learned some lessons over the years with that. Also, temperature is very critical with additive manufacturing. Hence the use of control thermocouples as well as these work thermocouples. So temperature measurement is very important in processing additive manufacturing parts for sure.
Now let's talk about the future. We have talked from 1983 all this way, how it has evolved, how your company has grown, different location, different needs, different processes, a lot of R&D. You've seen a lot of trends. You have given papers on shows, right? So you know this industry from quite a while. You've lived it. You have literate. I mean, and right now we're in a very disruptive way, disruptive time. That now with AI and volume not being like the king anymore, more about the EV, SpaceX sending stuff back and forth. What trends or opportunities you see in the horizon for commercial heat treaters, right? And how to adapt them, because to not a state-of-the-art commercial heat treat, but there are a lot of very good commercial heat treaters that are working very hard to get over there. But when they see things like rocket stuff, right, rocket work or defense work or medical, how can they give the jump to that? Because that costs money, right? What are the trends that you see and the opportunities that there are to be landed in the next 20 years?
Sure. Well, I'll go back to where we started, which was the word vacuum. We're going to continue to press the envelope of vacuum. We still believe that vacuum is the future and continues to be. The vacuum furnaces have really made great strides over the years, replacing traditional atmosphere furnaces or other type equipment. You read every now and then a commercial heat treat plant catches fire or even burns down from one of these furnaces that would have an issue, or mesh belt furnace, whatever. Those things do happen. With the vacuum furnaces, we don't have that. Everything is pretty much environmentally safe, which we talked about before. We've done too is here in our Souderton facility, we have an R&D center. So in other words, not only for our commercial heat treating, but as well as our furnace building people, customers come to us with issues and problems, and how can we process them for them? This particular department is actually headed by a PhD chemical engineer, and she runs the department. And we do a lot of work with powders. We do a lot of exotic materials like titanium and tantalum, where we're hydriding and dehydrating them. It's actually a scrap reclamation process, but where people give us these things and we're processing them and we hydride them where they can grind them up and they can make new powders out of them. So that's another whole area where we've really developed. Here at our Souderton facility, we have a scanning electron microscope, an SEM, so we can actually look at parts and where did the failure happen, and work with our customers on things like that. So that's been a driving force, and we do that throughout all of our plants as well. We work together on things like that. But we see the future, Carlos, continuing as vacuum. Yes, we branched out into the vacuum oil quench, but as I reiterated earlier, it's a very safe furnace. It's a good working furnace too. It took us over 2 years to develop the furnace and build it and engineer it, and we're looking to build more as need be.
Thank you so much, Roger. Roger, it's been great to talk with you about solar, the industry, vacuum technologies. What do you think the trends are going to be? It's been a pleasure talking to you. Now, let's go a little less technical. I do believe that one of the weaknesses or industry is that people with experience are retiring, and we're not replacing them at the same pace, right?
Correct. Yeah.
So so that's going to be a challenge for all industry, in-house and commercial heat treating, right? But what's a personal advice or story that you would like to share with the new generations or of engineers that are going to devote their career to heat treat, or something that is attached to heat treat, like building furnaces, right?
Sure,
what will be something that you would like to tell your younger self when you were 30 years old?
Okay, yeah. Well, quite frankly, I grew up in the business. When I was a teenager, I was out cleaning lights and helping out with various things, and I saw the business and I liked it, and I said I want to do this. So I went to school studying heat processing technology, as well as I've taken various ASM educational courses, as well as the MTI, which have been courses that I've taken, as well as business courses to facilitate the business. So a lot of that has been a major move. Now, let me just say this to the younger people. You know that the heat treating industry, it's not a real glorious thing, but I'll tell you, if you do it right, you can make money. Our company's an example. We started pretty much with used equipment when we started back in 1982, and here we are today in 2023 with 5 plants. Maybe looking to look at other areas of markets. We're looking at that for where's our 6th or 7th plant going to be. We're exploring that as well as building the equipment. So the advice to younger people is, get involved, ask questions, take some of these courses that are out there in the industry, the MTI, the ASM, online courses as well as in person. I'll tell you, an in-person course face-to-face is really the way to go. If you have to do it online, it's great too, but a face-to-face course with an instructor and where you can have a Q&A and actually get hands-on. We here in Satterton or other plants, we actually bring students, high school students, junior high school students through our plants, and we show them what we do to try to give them a taste, to try to put a little bit of a seed in the younger generation as to, hey, you could get involved with this, as well as universities. The local university here, Lehigh University, we have a great relationship with them. With every year they bring their students in, as well as others. So that's the key, Carlos, is getting to the younger generation. As older guys like me, I mean, I didn't want to just retire and sit on a couch and watch TV. I still work about 30 hours a week, which keeps me going and keeps my mind sharp, which I didn't want to just give it all up. And I worked out a great deal with my father and the company to do that, to continue to work and to continue to move forward. So you don't want to just give it all up. I mean, certainly I have some free time, but also I get involved and help out where I can.
Roger, thank you very much for sharing this wisdom with the audience, with the new guys. It's always a pleasure to talk to people that is passionate about the industry and has lived the industry, and especially you that you were actually born and raised next to furnaces. So thank you very much, Roger. Just would like to remind the audience that we're talking to power players of the industry like Mr. Roger Jones. Everyone, we're loading podcasts on YouTube, Spotify, and LinkedIn, so you can watch your information about heat treat from people like Roger Jones that had a full life working on heat treat. Thank you very much for doing this and sharing all this.